variables, on the depreciation rate delta, on the growth rate of technology G, on the population growth rate N, and on the share of production S that is being saved and invested, which means we can calculate where the economy is likely to be and also how changes in any of these things are likely to affect the overall level of prosperity. This is, as I said, interesting because if an economy is not on its balanced growth path, it's heading for there, and it will get there relatively quickly, at least in the 10 millennia historical span. It will get there in a couple of generations, in no more than a couple of generations. So now we can calculate, do a bunch of calculations about where the economy is and is likely to be over time. We can take our numbers for what the S, N, G, delta, and alpha, and E are at any one point in time, and that'll tell us the level of output per capita. And we also know how most of these quantities are behaving over time. We know that the labor force is growing at a constant rate N, which means that if we want to pick some year 0, and we know what the labor force is in that year, call that L sub 0, we can then just multiply that by 1 plus N t times to get what the labor force is up at year t. This is a handy bunch of formulas to have around, and problem set 2 is going to be applying them. How helpful is this model going to be in understanding the real world? Because we've done a bunch of algebra very quickly, and we've made a bunch of absolutely heroic and unrealistic assumptions. Have they produced anything that's worth anything at all? Right? It certainly won't get you onto the BART without a valid BART ticket, but is it useful for any other reason? Well, take a look up at the formula at the top, right, for output per worker in year t. Well, at first, there's going to be this term that I said was capital intensity, this S divided by N plus G plus delta raised to this power. That comes from the balance between savings on the one hand and savings requirements on the other that tells us how capital intensive the economy is. Then there's the level of the efficiency of labor back at year 0, whenever you started analyzing your economy. But since the efficiency of labor is growing at rate G, we know that we simply multiply that E0 by 1 plus G raised to the T power. That's going to tell us what our economy's output per worker level is. And note the N in the denominator here. That's the population growth rate. That tells us that if N is bigger, if the economy has a faster population growth rate, well, then it's going to have a lower capital intensity and it's going to be a poorer economy. Why is it going to be a poorer economy? Well, because of all the savings and investment done in the economy, not as much can be used up to build up the stock of machines and buildings that multiply the productivity of any one worker, but rather a greater share of savings and investment have to be devoted to building up new factories, new machines, and new buildings in order to provide employment for all the extra workers who are associated with rapid productivity growth. So other things equal, a country with faster population growth is likely to be poorer. Now, there is reverse causation here. Not just the case that a country with fast population growth is poor, it's also the case that a country that's poor has relatively fast population growth. That, in general, a country has to be rich enough that women learn to read and have options to work outside the home on a large scale before the population growth rate drops from its pre-industrial to its modern kind of level. If a country's poor, it's unlikely to have a literate female population, and unlikely for women to have many options to work outside the home. But even so, even allowing for reverse causation, it's pretty impressive what the relationship is between population growth on the one hand and income per capita, which is about the same thing as income per worker on the other. This being from the gapminder.org website, this from 2004, all the way from the United States, smack here, Japan, smack here, China, smack here, and this is what China's children per women was exactly in 2004. If you look at what the population growth rate of China had been over the preceding 60 years and what the average children per women had been over the preceding 70 or 80 years, it is up here. The fact that China's down here means it's in rapid transit to a lower population growth equilibrium, in large part as a result of the relatively stringent one-child policy. India, which didn't have a one-child policy, is not that far behind China in terms of falling fertility. And up at the far left, with still extremely high rates of population growth and fertility and extremely poor, you have Africa, the dark blue, with South Africa kind of here, about halfway between the richest of the rest of Africa and Europe. And what is this green thing? I bet you the green thing is Papua New Guinea. Well, I need to look up what the green thing is. And since I haven't set up my internet connection, I can't do it on the fly. So, this model tells you something useful about the relationship between population growth and prosperity, even taking account of the fact there's a bunch of reverse causation. How helpful is this model? Well, once again, back to our old equation up at the top. Right, S equal Y over L equals this savings rate divided by N plus G plus delta raised to this power times the efficiency of labor. And this time, let's notice the S in the numerator. A country that's saving and investing more is going to have a higher capital intensity, is going to have more capital goods per worker, and so its workers are going to be more productive, even if they're working with the same efficiency, simply because of the greater capital intensity. So other things equal, a country with a higher savings investment share will be richer. And there is reverse causation here as well. That is, a richer country, well, a rich country is one that's very good at making machines. That's one of the reasons that you're rich. And most capital equipment is machines. And so if you're good at making machines, the machines will be relatively cheap, so it'll be easier to devote a lot of your energy to investment. If so doing, you can do so cheaply. So there is reverse causation here. It's not just the case that countries with higher savings rates are richer. It's also the countries that are richer for other reasons have higher savings rates. Nevertheless, once again, you can see the pattern, although the pattern is not as strong as it was in population. You have some extraordinary outliers. Like Botswana, as it stood in 1980. A very large share of investment in machinery and equipment in Botswana, and yet extraordinarily poor. Anyone want to predict where Botswana is now? In spite of the AIDS epidemic, Botswana's kind of close to tripled its relative income as a share of U.S. Since then, in spite of having something like a fifth of its adults now HIV positive. Of course, embarrassing are Tanzania, Zambia, and Zimbabwe, which also had extremely high investment rates and have done extraordinarily poorly over the past 25 years. I would argue because those economies made much too heavy a bet on central planning by the government as an economic development strategy. When you're hiring your development advisors from North Korea, and they're advising you on your industrial structure, it's not likely to turn out well. Especially if, like Robert Mugabe in Zimbabwe, you also bring in people from North Korea to advise you on democracy and how to control the people. But nevertheless, there is a relationship there. And I would argue, or at least Larry Summers and I argued in a paper we wrote in the early 1990s, that if you kind of clean the relationship between prosperity on the one hand and investment on the other, of a whole bunch of other factors also influencing things that didn't make us into our very simple model, you get a much, much stronger relationship. That is, the fact that this particular scatter is not a terribly impressive one is because there are a bunch of factors that are important for growth but that don't make it into our simple model. And once we clean the model of those factors, well, we then have a much better picture. Except that something's going wrong with Costa Rica. Costa Rica ought to be much richer than it is. And something's going wrong with Finland. And something's going very right with Hong Kong. We think what was going right with Hong Kong was that in 1985, when we actually took a snapshot of how prosperous it was collecting enormous rents for being virtually the only open window into the Chinese economy. But even though this was 7 years after the start of Deng Xiaoping's reforms, you still, if you wanted access to China's production and China's market and China's labor, you had to go in through Hong Kong. And Hong Kong managed to profit enormously from that. Costa Rica, we never found a terribly good explanation for, nor Peru. Finland, the problem was it was so tightly coupled to the economy of the Soviet Union, and the economy of the Soviet Union had an absolutely horrible 10 years before 1985. So we could attribute it to that. We were happy. This convinced us, at least, that this economic growth model had a good deal to contribute. Now let's ask how this lecture's gone. In trying to do an awful lot, and trying to do an awful lot quickly, on the grounds that it's useful to go over this stuff once verbally, but I at least find I really have to learn this stuff from the textbook, or it doesn't stick, and I want to get on to stuff to actually using the model, because that's what it's for. I don't want you to remember the derivation. I want you to be able to use this to make calculations and assess situations. Oh dear. No too slows. I guess the plurality has to rule. Too fast. Okay, next time I go through a model like this, I'll try to go more slowly and more coherently. But what I'm going to want you to get out of this is not how I derive these conclusions. For that, you can always go back to the textbook if you want to derive them. I want you to get out the particular rules of thumb. And the most important rule of thumb is this growth equation here. So let's see if you can apply it. Let's suppose that our savings rate is 20% of GDP is 0.2. Let's suppose that our population growth rate is 0.01, is 1% per year. Let's suppose that our efficiency of labor growth rate is 2% per year, 0.02. Give us a depreciation rate of 0.02 and an alpha of 0.5. What then is y over L going to be in this particular economy? It's very hard to do, especially if you haven't done it before. The right way to do it is to note that if you add up ng and delta, you get 0.05. And if s is 0.2, then 0.2 divided by 0.05 is simply 4. And if you notice that if alpha is 1/2, then alpha divided by 1 minus alpha is simply 1. So that all of this first bunch of stuff in here, this is simply 4 raised to the first power. And with e at 10,000 per year, we get 40,000 per year. Okay. I'm tempted to give credit for e, but I'll give people credit for a as well, since that's the right answer. Well, let's try another one. Let's keep the efficiency of labor at 10,000 per year, but let's let the savings share go up to 27%, and let's lower a couple of other things. What then is the economy's level of output per worker likely to be? Tricky part of this is seeing that if alpha is 1/3, then 1 minus alpha is going to be 2/3, and that 1/3 divided by 2/3 is 1/2. And to remember that if you're raising something to the 1/2 power, you're simply taking its square root. So what we're going to have here is we're going to have 0.27 over 0.03, that's 9, and then we're going to be taking the square root of 9, that's 3, and then we're going to be multiplying 3 by 10,000, and that's going to give us, oh, excellent, that's going to give us 30,000. Oh, that's good, that gives me a great deal of hope for how people are going to do on problem set 2. Let me finish simply by going back to the second number that I want you to have drummed into your heads. You got it yet? How much is the unemployment rate out there today? Yep. Okay, you nailed it. Congratulations. Next time, we'll apply our growth model to try to understand what's going on in the world today and what has been going on over the past 2 centuries.